These are the notes for Algebra 2, Section 4.5. This is actually Part 3 of Section 4.5. And this part deals with solving equations using square roots. Now, using square roots to solve equations is something different than what we've dealt with before. So we want to look at the peculiarities that pop up when we use them. Now, when would we use a square? Well, if you're solving a quadratic equation, that is an equation that has an x squared term of some kind, you can take the square root of an expression to cancel out that square. What that means is if, for instance, I had x squared equals 16, in order to figure out the value for x, I need to cancel out this square, just like I would need to cancel out any other operation being done to x. To cancel out a square, we take the square root. And if I take the square root on one side, just like every other operation, I have to take the square root on the other side. And the magic happens because the square root of a squared term cancels each of those things out, and we would just be left with x. So x would equal the square root of 16. Now we know that the square root of 16 is 4, but when you take the square root of an expression in an equation, you always have two answers. And we delineate this, and I'll just carry this equation on down here. If I have x equals the square root of 16, the square root of 16 in this case is either 4, because 4 times 4 is 16, or it is negative 4, because negative 4 times negative 4 is also 16. So, we need kind of an easy way to write that, and we'll see what it is a little bit later on. But this is our basic idea. We can cancel out a square by using a square root, and when we take the square root in an equation, we should always have two answers, one positive and one negative. Alright, let's move on. Let's look at an example. For the most part, the things that we do in equations are the same regardless of whether we use square roots or not. Square roots are just another tool that we can use to solve equations. Now, the equation I want to solve is 1/4 y minus 6 squared equals 4. So this is the equation I want to solve. A lot of the steps are going to be familiar. The only one that's different is this square rooting. Now we start with the original equation. And what we want to do is get rid of this 1/4 first. We got to get rid of that. Because in order to take the square root, the term being squared, or the expression being squared, has to be the only thing on its side of the equation. This 1/4 is in the way. I can't take the square root until I get rid of the 1/4. Now, to get rid of the 1/4, I multiply it by 4, because 4 times 1/4 cancels out. But if I multiply the left side by 4, I have to multiply the right side by 4. I have to multiply each side by 4. Now, when I do that, 4 times 1/4 cancels out, and I'm just left with y minus 6 squared. On the other side, 4 times 4 is 16. Now here, my magic next step is to take the square root of both sides. That is the next thing that I want to do. When I do that, I'm going to take the square root of y minus 6 squared, the whole expression, and the square root of 16. Now we've already seen that the square root of something squared cancels each other out. So on this side, we just have y minus 6. Now on the other side, I have the square root of 16. But here's the thing. We know that the square root of 16 is either 4 or negative 4. Now we want to be able to write the idea of 4 or negative 4 as quickly and easily as possible. So we have to use a new symbol here. We're going to use a symbol that might be unfamiliar. In this case, if I take the square root of 16, I'm going to say that the square root of 16 is either positive or negative 4. Now this is the symbol that's new. Positive or negative 4. You notice I have a plus sign and a negative sign sitting right on top of each other. That indicates that I either have positive 4 or negative 4. Either one. Now here's the thing. I can keep going as I normally would, but I have to keep in mind that I actually have two answers here, positive 4 and negative 4. So my next step would be to add 6 to each side, right? Plus 6, plus 6. But when I do that, and they cancel out on one side and give me y, on the other side, I have 6 plus or minus 4. 6 plus or minus 4. That means I either have 6 plus 4. That is one answer. 6 plus 4 or 6 minus 4. That means two possibilities. Either 6 plus 4, 6 minus 4. So either y equals 6 plus 4 is 10, or y equals 6 minus 4 is 2. And those are my two separate answers. They are both solutions. Alright, let's try a different problem. This process is going to be the same. A few things we need to keep in mind, of course. We have these square roots that we use to get rid of the square symbol. When we take the square root inside the equation, we have plus or minus. So we have to keep that in mind when we're looking at answers. Now, let's look at example number 2. Example number 2 says 4 times x minus 1 squared equals 8. I took away the step-by-step guides. We're going to be able to do this one on our own. So let's start. Now, the first thing that I want to do, I have 4 times this expression squared equals 8. And the very first thing that I have to do is get rid of this 4. I can't have that 4 when I take the square root. So let's do that first. Let's start by dividing both sides by 4. I divide both sides by 4. That cancels out these 4's. And I end up with x minus 1 squared equals 4, or 8 over 4 is 2. So x minus 1 squared equals 2. Now I have a squared expression on the left side. I have a regular number on the right side. That's where I need to be. Okay, that's where I should be at this point. To get rid of this square term, I take the square root. So I'll take the square root of the entire expression. I have the square root of x minus 1 squared cancels out the square term, and I'm just left with x minus 1. Now on the other side, I have the square root of 2. Well, I can't really simplify the square root of 2. We saw that when we were simplifying radicals. So instead, I just have plus or minus the square root of 2. All right, plus or minus the square root of 2. Remember that plus or minus symbol has to be there. That is a required part of the answer. And this is where it should be put in. After you take the square root and done any simplifying that you can do, there should be plus or minus the square root of whatever. And in this case, 2. Now I want to get x by itself. I'm still trying to do that. So I add 1 to both sides. That gives me x on one side and 1 plus or minus the square root of 2. And what this means is that either x equals 1 plus the square root of 2 or x equals 1 minus the square root of 2. Now we've seen that we can't actually subtract these two terms. We're just going to leave it 1 plus the square root of 2 and 1 minus the square root of 2. We don't want to add or subtract whole numbers and square roots. That's not generally done. So these are my two solutions. Okay, we have one last thing that we want to look at here, and this involves a piece of vocabulary, and it has to do with the height function. Now the height function models the height of an object as it's being dropped after a certain number of seconds. So the height h of an object being dropped after t seconds. This is the height function. H equals negative 16t squared plus h sub 0. We say this is h sub 0. Now, the parts that we have here, just to give us an idea of what we're actually looking at, this h is the height of the object. Right? Whenever we figure out what the height is, that's the height of the object. Now this negative 16t squared, that is how far the object has fallen. And the last part is this h sub 0 here, this h with the little 0 after it. And that is the starting height of the object. So we have the height that we ended up with. We have the starting height, the initial height of the object. And then we have negative 16t squared, which tells us how far the object has actually fallen since we started dropping it. So let's use this function to solve a problem. Now, we have a water balloon dropped from a window 59 feet above the sidewalk. How long does it take for the water balloon to hit the sidewalk? Essentially, we want to know when the water balloon will hit the sidewalk when the height is 0. And that's usually the kind of question that we're being asked. Height equals 0. So when we're actually working out this problem, we start by writing the height function down. H equals negative 16t squared plus h sub 0. We want to substitute in 0 for h because that's what we want to know. When is the height 0? When does it hit the ground? And we want to substitute in 59 for the starting height because that's where it starts. All right, now we subtract 59 from both sides, and when we do that, we get 0 minus 59 is negative 59 equals negative 16t squared. So here we're going to divide each side by negative 16, and if I divide negative 59 by negative 16, I should end up with about, and this is going to be a fraction, I'm just going to round it, about 3.7. All right, it's actually 3.6875, but I'm not going to deal with all that. It's about 3.7. Now that's t squared. I want to know t. Well, t is either the square root of square root of 3.7, which is positive or negative. Keep in mind we are doing an equation. That means we do have to have the positive and negative symbol. Positive or negative 1.9. Now, we used the calculator to do all that, And our answer then is about 1.9. We could say it's negative 1.9, but we don't really have negative time, a lot like we don't have negative direction or negative distance or any of that kind of stuff. So we're going to reject the negative solution. We're going to say that one doesn't work. Time must be positive. That means that the balloon will fall about 1.9 seconds before it hits the ground. Now, I need you to solve the checkpoint problems that are on the bottom of the page and bring them to class with you.